Hello friends, in this video we'll see practice problem on matrices. Problems based on matrices, specifically introduction of matrices. If a matrix has 8 elements, what are the possible orders it can have? What if it has 5 elements? Now we know that for any matrix, rows into columns will give you total number of elements. That means suppose if it is a 2 by 2 matrix, then 2 into 2 will give us 4. So any 2 by 2 matrix will have 4 elements. Suppose you have 2 by 3 matrix, that means if there are 2 rows and 3 columns, then 2 into 3 will give you 6. So any 2 by 3 matrix will have 6 elements and so on. Now in this question they have given us that there are 8 elements and we need to find out what are the possible orders it can have. Now there are 8 elements. How we can write 8 in the form of product of two numbers, that is we can write 8 as 1 into 8 or 2 into 4 or 4 into 2 and reverse of 1 into 8, that is 8 into 1. That means ultimately possible order of that matrix is 1 by 8, that is this matrix can have 1 row and 8 columns. So suppose if you imagine a matrix with 1 row and 8 columns, so there will be total 8 elements. Similarly 2 by 4 also gives you the product as 8. So it can have 2 rows and 4 columns. 4 into 2 also gives you the product as 8. So the matrix can have 4 rows and 2 columns. And ultimately 8 into 2 is also equal to 8. Hence this matrix can have 8 rows and 1 column also. So supposedly what are the possible orders it can have? So ultimately, to answer the question what are the possible orders it can have is 1 as to 8, 1 by 8, 2 by 4, 4 by 2 or 8 by 1. Now suppose there are 5 elements. Now which two numbers can give you product as 5 is 1 into 5 or 5 into 1. So possible orders of the matrix is either 1 by 5, that means 1 row and 5 column, or 5 by 1, that is 5 rows and 1 column. Moving to next problem. Let A be a matrix of order 3 by 4. If R1 denoted the first row of A and C2 denotes its second column, then determine the orders of matrices R1 and C2. Now we'll visualize this matrix first. So A is given as it is a matrix of 3 by 4. That means A will have 3 rows and 4 columns with the elements such as A11, A12, A13 and A14. In second row it will have A21, A22, A23 and A24, and in the third row it will have A31, A32, A33 and A34. Now which elements are there in R1? R1 is, that is first row. So R1 is equal to A11, A12, A13 and A14. So what is the order of R1? Order of R1 is 1 as to 4, that is 1 row and 4 columns. Similarly, as for C2, we have second column of this matrix A, that is A12, A22 and A32. That means there are 3 rows and a single column. Hence order of matrix C2 will be equal to 3 as to 1. Construct a 2 by 3 matrix A is equal to Aij, whose elements Aij are given by Aij is equal to I into j, Aij is equal to 2i minus j, Aij is equal to I plus j, Aij is equal to I plus j bracket square upon 2. Now we know that for any matrix, capital letters denote the name of the matrix. So in this case, this capital A denotes the name of the matrix, whereas this small a denotes the particular elements. Now this I and J signifies the rows and columns. Specifically, I signifies rows and J signifies its column. Now we'll calculate all these four matrices one by one. So in first case, Aij is given as A I into J. Now for the first element of this matrix will be A11. Now in this case, I will be equal to 1 and J will be equal to also 1. Hence A11 will be equal to 1 into 1, that is 1. Similarly, we will calculate all the elements. So A12 will be equal to 1 into 2, that is 2. A13 is equal to 1 into 3, that is 3. Now we'll move to second row. So element A21 will be equal to now I into J. Value of I is 2 and value of J is 1. So A21 is equal to 2 into 1, that is equal to 2. A22 will be equal to 2 into 2, that is 4. And ultimately A23 is equal to 2 into 6. So we'll write this matrix, that is now this one will come here. This 2 is first row second element. This 3 is first row third element. Now second row first element, second row second element, and second row third element, and so on. So similarly for all other matrix B, C and D, we will calculate the matrix according to the given condition. So in second scenario, it is given as Aij is equal to 2i minus j. So for the first element A11, it will be equal to 2 into 1 minus 1, that is 2 into I minus j. Now for the first element, I is equal to 1 and j is equal to also 1. So A11 will be equal to 2 into 1 minus 1, that is 1. A12 will be equal to 2 into 1 minus 2, that is 2 minus 2 is equal to 0. A13 will be equal to 2 into 1 minus 3, that is minus 1. Now moving to second row, A21 is equal to 2 into 2 minus 1, 4 minus 1 will give you 3. A22 is equal to 2 into 2 minus 2, that is 2. And A23 is equal to 2 into 3 minus 3, that is equal to 1. So in second case, matrix A will be equal to 1, 0, minus 1 and 3, 2, 1. Moving to third case, in third scenario, Aij is given as I plus j. So A11 will be equal to I plus j, that is 1 plus 1 is equal to 2. A12 is equal to 1 plus 2, that is equal to 3. A13 is equal to 1 plus 3, that is equal to 4. Moving to second row, A21 is equal to 2 plus 1, that is equal to 3. A22 is equal to 2 plus 2, that is equal to 4. And A23 is equal to 2 plus 3, that is equal to 5. So in this case, matrix A will be 2, 3, 4 and 3, 4, 5. And in last case, Aij is equal to I plus j bracket square upon 2. Now in third case, you have already calculated I plus j. So we'll just make a square of that of all those elements and divided by 2. So A11 is equal to, now what was A11 in third case? That was 2. So 2 square is 4. 4 divided by 2 is equal to 2. Now A12 in previous case was 3. So in this case, A12 will be 9 upon 2. Similarly, A13 will be 4 square upon 2, that is 16 upon 2. A21 will be equal to 3 square upon 2, that is 9 upon 2. A22 will be equal to 4 square upon 2, that is 16 upon 2 is equal to 8. And A23 will be equal to 5 square upon 2, that is 25 upon 2. Hence your matrix is 2, 9 by 2, 8, 9 by 2, 8 and 25 by 2. Now here 9 by 2 and 25 by 2, you can keep these elements as in the form of fraction only. You are not supposed to convert them into decimal form. Moving to next problem. Find x, y and z so that A is equal to B, where now matrix is given, matrix A and B are given. So A is equal to x minus 2, 3, 2z, 18z, y plus 2, 6z, and matrix B is also given. B is equal to y, z and 6, 6y, x and 2y. Now it's given as matrix A and B are equal. Now matrix A is also 2 by 3 matrix and matrix B is also 2 by 3 matrix. So all the elements of matrix A are equal to respective elements of matrix B. So suppose if you compare each element of matrix A to each respective elements of matrix B, you can get three different equations in order to calculate the value of x, y and z. Now we'll compare this second column, first row, second column, that is 3 is equal to z. Hence we can, just by observation, we can get the value of z. Now if you compare this second row, third element, so 6z is equal to 2y. Now we have already got the value of z. Hence 2y is equal to 6z, that is 6 into 3, which is equal to 18, and hence y is equal to 9. Now it's also given as x minus 2 is equal to y. So we'll put the value of y, that is x minus 2 is equal to 9, and hence x is equal to 11. So ultimately solution for this problem, x, y, z is equal to 11, 9 and 3. Moving to next problem. Find the values of x and y if x plus 10, y square plus 2y, 0 and minus 4 is equal to 3x plus 4, 3, 0 and y square minus 5y. Now in this problem, two matrices, it's given as these two matrices are equal. Both the matrices are 2 by 2 matrix. Now we will compare the elements and will calculate the value of x and y. Now in first case, x by 10 is equal to 3x plus 4, that is first element of first row of both the matrices. So x plus 10 is equal to 3x plus 4. Now if we rearrange the equation, we will get 2x is equal to 6 and x is equal to 3. Now in second case, you can either compare y square plus 2y is equal to 3, or you can compare y square minus 5y is equal to minus 4. We'll start with y square plus 2y is equal to 3. Now if I rearrange this equation, y square plus 2y minus 3 is equal to 0. This is quadratic equation, so you need to factorize this. That is y square plus 3y minus y minus 3 is equal to 0. So y into bracket y plus 3 minus 1 into bracket y plus 3 is equal to 0. Hence y minus 1 and y plus 3 is equal to 0 will give you two values of y. So either y can be 1 or y can be minus 3. Now there is one more equation given as y square minus 5y is equal to minus 4. So if we put the value of minus 3, then y square minus 5y will be equal to 9 plus 15, and which is definitely not equal to minus 4. Hence we will try with another value of y which is equal to 1. Then in that case we can get y is equal to y square minus 5y will be equal to 1 square minus 5, that is minus 4. Hence we can take only this value of y, that is 1, and hence solution to our problem is 3 and hence solution to our problem is 3 and 1. Moving to next problem. Give an example of a row matrix which is also a column matrix. Now what do you mean by row matrix is which have only one row and multiple columns. Similarly, what do you mean by column matrix is which have only one column and multiple rows. Now the matrix should be row matrix as well as column matrix. So any 1 by 1 matrix will be a row matrix as well as column matrix. So here I have just taken 10 as an example. You can take any value as in A, B, C, 10, 100, anything. Give an example of a diagonal matrix which is not scalar. Now what do you mean by diagonal matrix? In diagonal matrix, all non-diagonal elements are 0. And what do you mean by scalar matrix? A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. So now in this case, first thing which we have to follow is all the non-diagonal elements are 0 and it should not be scalar. That means diagonal elements should not be equal. So I have just put in 1, 2, 3 as a diagonal elements. So matrix A is equal to 1, 0, 0, 0, 2, 0 and 0, 0, 3. Give an example of a triangular matrix. Now what do you mean by triangular matrix? Actually there are two types of triangular matrix, lower triangular matrix and upper triangular matrix. Any square matrix is called as lower triangular matrix if all the entries above the main diagonal are 0. Similarly, upper triangular matrix, all the entries below the main diagonals are 0. Now here, let's suppose this 1, 2, 3 is your main diagonal. Then all the entries below this diagonal are zeros. Hence, it is a upper triangular matrix. Now, in this video, we have seen few practice problems on introduction to matrices. We will cover few more practice problems on matrices and determinants in upcoming videos. Thank you.